Hey there, just want to make sure you can hear me. Awesome. Right, we're going to get started in about 3 minutes. Hey folks, it's so good to see you here. I'm just going to do a little audio test. If you could, in the chat, let me know if you can hear me. That would be fantastic. All right, I just want to make sure. Hey, I appreciate it. Thank you. All right, we're going to get started in about a minute. I'm going to put the link to Pear Deck in the chat as well as the code. We've got just a little bit more time here. All right. So, hey, welcome so much to Fiveable Streams tonight. And tonight we're going to do AP Physics 1. We're going to take a look at dynamics. So one of the things that I love to do is have you be interactive, which means I want you to answer some questions. I'm going to use something called Pear Deck tonight. If you've used Pear Deck, that's great. If you haven't used Pear Deck, this is an awesome way for you to come in and be able to interact. I can see your answers and I can see who you are, but when I project some answers on the screen, you will not see any names. So this is totally anonymous. We want you to make mistakes. Excuse me. So as we go through, sorry about that, had to get a drink. So as we go through, we'll just make sure that just know that we won't project your name. All right, here we go. I'm going to copy a link. I'm going to put it on the chat. All right, there we go. So when people come in, we'll just keep sticking that on the chat. So if you can, go ahead and log in, and we're going to go ahead and get started. So I'll just keep putting this in the chat. Welcome again. This is Fiveable AP Physics 1, and we are going to go through and talk about dynamics tonight. So this is a pretty big topic. You'll definitely want to be ready for this, and just know that most questions have some sort of dynamics on them. Hey, just a heads up, this stream is being recorded, and you might appear on the website. You might be on YouTube or other public channels. The other thing you need to know is if you ask a question, your name will appear on the screen. So please change your name if you want to avoid this. All right, here we go. Don't forget to promote what you see. So if you like what you see, go out, tell other people about it. Just use @thinkfiveable on either Twitter, Instagram, or on YouTube. So any of those platforms would be awesome. So I'm going to keep putting the link to Pear Deck in the chat. So as you come on, I'll just remind you every once in a while to do this. Hey, our next topic is on March 20th, and it is at 3 p.m. So that is on Saturday, not this Saturday, but a week from Saturday, and it's on circular motion and gravitation. On March 26th, 6 days after that, on a Friday night, that's going to be energy. And then the following Saturday at 4 p.m., we are going to go through and do some Pear Deck on momentum. So hopefully that's super helpful. Things that we're going to talk about tonight, we're going to look at what is force. We're going to talk about the types of forces. There are two things you need to know about forces as you go through. We'll look at Newton's 3 laws, balanced and unbalanced forces, as well as Atwood's machines in incline planes. So if you've just joined us, there is a link in the chat that shows you how to log on to Pear Deck so you can take part. The first thing we're going to just kind of look at for a second is what is a force. So remember, a force is a physical quantity, is something that you can measure, and this measures and models what we would term a push or a pull. It is a vector, so that does mean that it has both a magnitude and direction. The magnitude is measured in newtons, and the direction for this one is up, down, in, out, left, right. Anything you can think of that would tell direction, you can use with a force. So there are several different types of forces that you're going to encounter on the AP Physics 1 exam. The first one, and probably one of the most important, is weight. Be very, very, very careful with this one. I'll tell you that when we read these exams every year, we sit down, and each person who is reading your exams is a physics teacher, either a college or a high school physics teacher. And we are looking for you to be very good about being specific about forces. So you need to say not force of gravity, but force due to gravity. Remember, gravity is an acceleration. So we always want to say the force due to gravity or weight. When you label free body diagrams, the most important thing I can tell you is I would use mg. That way, if you need to solve for the mass of an object in a force problem, you'll be able to do that pretty easily. If you use fg or w, you'll probably have to change it at some point to mg anyway. Remember that this direction of this force is always towards the center of the Earth or other satellite or planet. And we typically see the equation as Fg equals mg. Now, this equation just in this form is not on the equation sheet. But if we go to the AP Physics 1 equation sheet, I do want to show you this. If you type into Google AP Physics 1 equation sheet and then click on the very first link, you will see the AP Physics 1 equation sheet. We're going to move down to where all the equations are, and then I'm going to show you that equation isn't on the equation sheet like this. So you won't ever see Fg equals mg, but what you will see is g, the acceleration due to gravity, is equal to the force of gravity divided by mass. So that's super important to take a look at. Just remember that this is the equation that you want. While we're on the equation sheet, I do want you to see some other equations for force. We do have the force due to gravity between two objects. So you'll see this. These two are related in that this one is specifically for Earth. So we're thinking about when you're on Earth and acceleration due to gravity. It could be for the moon. As long as you know the value for g, you can use these. There is the force of a spring. You'll see this over on the left-hand side. And as we move up, you're going to see another one that deals with torque. So if you've been through rotational motion, you knew that one. We do things with change in energy at work. We typically look at force, and we know that it's force in the parallel to the distance. So if I push something to the right, it's going to move. And then we've got a couple more. One of them is the force of friction. And the last one is the very important one. And notice that it's not F equals ma. Instead, it is the acceleration of an object is equal to the net force acting on it divided by the mass. So those are the equations that you'll want to kind of remember as we go through. And now let's look at the next force, which is the normal force. Remember, this is the one that is perpendicular to the surface. That's what the word normal means. And there is not an equation on the equation sheet for it. Tension is Ft. It is parallel to the rope. The friction force is either F, and it's either kinetic or static. So it depends on what's happening. Remember, kinetic is sliding friction, kind of like if you're drifting around a corner. And static friction is when something makes contact with the surface and sticks to the surface. And that is parallel to the surface also. The last one is spring force, and this one is also parallel to the spring's axis. So you'll notice that our normal force is the one that is perpendicular to the surface. All things, or two things about forces, all forces have two things in common. The object, that's the thing that the force acts on, and the agent, and that is the thing that is doing or the pushing or the pulling. So this is where you get to be active. You should be able to draw on this slide. And what I would love for you to do is grab a pen and go ahead, and I would love for you to circle what you think is the correct answer. Now remember, I can see your answers and your name. Nobody else can at this moment. When I show everybody answers, the only you won't be able to see anybody's names. So go ahead, take a guess. And once you take a guess, we'll show some of these responses and we'll see how we're doing. So good job. Excellent. So even good. Tom, excellent. Pratush, very good. Excellent. Alex, good. So I'm seeing lots of great responses here. So notice it does say two forces. Good job, Lily. Awesome. So we've got a couple Lilies here. You folks are doing great. Thank you for participating in the Pear Deck. That just makes things so much easier. Awesome. Very good. Grace, good job. All right, so let's go ahead and take a look at what everybody's saying. And so the two forces that this first person picked were the force due to gravity and the normal force. Same thing for this person. They also drew a free body diagram. Way to go. That is beautiful. Here's another one with the free body diagram. Very good. Excellent. So it looks like we're saying that it is the force due to gravity as well as the normal force. So that is the correct answer. One of the things that I did to kind of help you out just a little bit is I have on the slides made sure that I give you the answer, but also give you an explanation. And one of the things that I love to do is to use an explanation that includes B, C, D. So I've answered the question over here. And so what I love to have students do is to answer questions using the A, B, C, D format. And I'm going to tell you what each one stands for. So A stands for answer. B stands for basic physics. You'll notice that we've answered the question by choosing the two correct forces. That is the force due to gravity and the normal force. We then included the basic physics. If you're asked to explain whether it's a paragraph length formation or just a short explanation, if you use BCD, it will make it really nice. You'll probably get all your points and you won't forget anything. So if the basic physics for this one is the force of gravity points to the center of the earth and the normal force is perpendicular to the surface. That helps us identify the physics that is in the picture. We need to cite evidence. So now we're going to say that the bird is pulled down by the earth and the perch pushes up on the bird. And that is cite evidence. So that's what we see in the picture. And then finally, the last thing we're going to do is draw it together. So I want to draw my basic physics, my cite evidence together. And I'm going to say, since the earth pulls down on the bird, and that's the force due to gravity, and since the perch pushes perpendicular to the bird, that would be the normal force. So just a good way of trying to explain what it is that is happening in this picture, just in case they ask you to explain. Do remember that the AP Physics 1 exam, you'll barely use your calculator at all on the free response. It's mainly explaining things. So you'll want to get used to that. And one of the best ways to do it is to use that A, B, C, D format. So awesome job. Now, the bird is sitting motionless on the perch. For each force, we do know there's two objects, so we now know what the objects are. For the force of gravity, what is the force acting on, and by what object does it come from? So for the force of gravity, what is the force acting on, and by what object does it come from? And I want to just give a shout out. We've got Brianna here tonight. She is our AP Physics 1 TA. She is phenomenal. She knows all kinds of physics, and she is super useful when you have questions. So one of the things that you could do after we get done tonight is go to Discord and ask any questions that you have about what we did tonight. Love to see what kind of questions you have. So I'm seeing a lot of awesome answers here. Everybody looks like they've got this one correct, which is what I absolutely love to see. So let's take a look and see what some of your answers are. I did, if you've just come in, I did put the link to the Pear Deck in the chat. So if you want to click on that link, you'll be able to join us and you can kind of see what other people are doing. All right, here we go. So this person does have the correct answer. It is the bird on the earth. And in fact, I love Pear Deck because I can stack these things together. And we see that we had maybe a couple people answer A and a couple people answer C. We want to be really careful because remember, the bird is pulled down not by the perch. The bird is pulled down by the earth. The perch does something else. And remember Newton's third law. When you pull this bird down by the earth, the bird also pulls up on the earth. But because the bird doesn't have much mass, it doesn't really affect it much. Okay, so you have to remember that too. Very good. I love all the pictures that are here. You guys are doing awesome. And hello, here we go. Here's my answer. Remember, I will always put on the explanation. So this is going to be in the format of BCD. So I just said there's a Newton's third law pair here due to gravity involves the earth and always involves the earth when you're on the earth. And the object on which the force acts, we do know that the bird is pulled down by the earth and the bird pulls up on the earth. So it explains that third law. And since the bird is pulled down by the earth and the bird pulls up on the earth, they compose a Newton's law third pair, a Newton's third law pair. Excellent job. Here we go. Next question. For the normal force, what is the force acting on and by what object does the force come from? So remember, we are looking at the bird. So we're looking at the bird. You'll notice in the question, it does say a bird, that is our object, is sitting motionless on a perch. So let's go ahead and see if you can pick the right one. We're seeing some good answers here already. Good job, Gabriella. Good job, Pratish. Gisela, very good. Job, Tom. Spandan. Excellent to see you tonight. Lily, good job. Alex, good. All right. Very good. So make sure you answer. It's always a good thing to answer just to check and see if you're right. Remember, it's okay if you're wrong. Not a big deal at all. That will help you kind of check your answers and see how you're doing. Seeing some awesome answers here. All right, cool. Let's check and see what a majority of people have said. All right, cool. Here we go. So let's show the responses. Yeah, I love this. Somebody said, so the bird doesn't sink into the perch. And that's correct. The perch has got to have that normal force pointing up, and the bird is then pushing down on the perch. So nice job with all the free body diagrams. I love that. Excellent, excellent, excellent. So here is our correct answer. And I'll show you the answer again. Remember, we do want to make sure that you understand how to answer the question, and not only that, but also to give a good explanation. So we've been talking about the answer using basic physics, cite evidence, and draw it together, or the ABCD format. Some of you probably use claim evidence reasoning, and that's okay too. But I like the ABCD because it includes the word basic physics. All right, let's take a look at the next thing. Newton came up with how many laws to describe motion. So go ahead and put into that blank a number. So how many laws of motion did Newton come up with? Starting to see some awesome answers here. Some people are typing an answer and spelling out the number, and other people are just putting the number, which is great. All right, so this one is definitely 3. So there are 3 laws of motion. We're going to talk about these 3 laws of motion really quick because I think it's important to clear up some misconceptions. So we do have Newton's first, second, and third law. Not a very difficult thing to remember. Pretty easy to do. It's not like if you've done chemistry, you know there are thermodynamic laws, and some of them have some special names. So these are a little bit easier. In Newton's first law, there is a terrible definition, and unfortunately, a lot of people use it, including a lot of college professors. So if your college professor says this, stand up and correct him. Well, you may not want to do that. One thing that you'll want to do is always remember that an object in motion, okay, if it stays in motion and an object at rest stays at rest unless acted on by an outside force, that is a terrible definition, because let's think about this girl. This girl is standing here and she's acted on by several outside forces. This girl is pulling her to the left. This girl's pulling her to her right. These people are pushing her up and gravity is pulling her down. So why isn't she moving? That's the question I have. So the answer here is really making a better definition. If there's no net force on an object, then the object remains stationary or moves with a constant velocity. It's the word net that really is the difference here. So if we go back, notice, unless acted on by an outside force, we want the word net. Now, why do we want the word net? Look at the equation sheet. You'll notice that when we look at the force equation, which we're going to make really big here, you'll notice they never put just F when they have F, M, and A. They put sum of the forces or the net force. Basically means the same thing. So we want to remember, if there's no net force on an object, then it remains stationary or it moves. So really important to recognize that. Here's the next one. This is a poor definition again for Newton's second law. It says force equals mass times acceleration. Well, the problem with this one is, think about this person. They're using a force, and let's say that they are just holding the weight right here. They are pushing with a force. There is a mass there, but the problem is it's not going up or down. It's not accelerating. So instead, we need to change this definition to an object's acceleration is the result of the net force on the object divided by the object's mass. So I need to go through and see that for this person pushing the weight up, if they're pushing up with the same force as the Earth is pulling down, then it will not accelerate. So you have to be very careful. The truck here normally will pull a little tree out from behind the big tree. It looks like it's hooked to the big tree. Unfortunately, the animated GIFs aren't working here. So you'll have to imagine the truck moving to the right. And so again, remember, it's the result of the net force. So you got to be very careful with that. Here's the third law. And this is probably the one that is the most abused. People say for every action, there's an equal but opposite reaction. Well, if I pull a child in the wagon moves forward. But if I pull on the wagon and the wagon pulls on me and it's equal and opposite, why does the wagon go somewhere? So remember, for this one, you have to think about all of the forces together. So in this picture, there's a lot of different forces. We have the force between the first child, the child in the front, So his hand and the wagon handle. So there's an equal and opposite force there. So those two forces by themselves would not move the wagon. If we put all these people in the space station and this person tried to pull on the wagon will put back with the same force and it wouldn't go anywhere. You have to be looking at the whole picture. So remember, this person is pushing on the ground. When they push backwards on the ground pushes forward on them. And if that force is greater than the equal and opposite force here, then this person, okay, so this child can move that wagon handle to the right. And if that force is bigger than the force of friction between the wheels and the ground, then the little girl will take a ride. So that's what we want to do when we think about Newton's third law. Let's take a look at balanced forces. There are a couple of cases when we think about balanced forces, either no movement and no acceleration or constant velocity. When we do this, we know that the sum of the forces is going to be equal to 0. So we're going to take a look at some problems where that actually occurs. If we have unbalanced forces, this is where things will be able to speed up or slow down. And if you were with us last week, you'll remember that if I have positive velocity and positive acceleration, then I'm speeding up. I can also have negative velocity and negative acceleration, and that is also speeding up, but in the negative direction. If I'm slowing down, I'm either going to have a positive velocity and a negative acceleration, or a negative velocity and a positive acceleration. They have to be in opposite directions. Regardless of whether something's speeding up or slowing down, there is a net force. So you'll notice that the sum of the forces now is equal to the total mass of your system times the acceleration. So that's different than when the sum of the forces is 0. All right, you're tired of hearing me talk. Let's do some things that are interactive. I want you to pick the right answer. So while driving down the road, a grasshopper strikes the windshield of a bus and makes quite an obvious mess in the front of the face of the driver. So which of the two forces is greater, the force of the grasshopper on or the force of the bus? Which one is greater? So you get to vote here and go ahead and do it in Pear Deck. I'm going to put the link to the Pear Deck back into the chat again, just in case. We've got a few people answering. You're doing a really good job here. Excellent. Got some more answers. Got some people changing their answers too. That's phenomenal. I like it. And this is what I love to see because we've got a couple answers here. Very nice. So we're trying to figure out which force is greater, the force on the grasshopper or the force on the bus. So we're going to give you about 10 more seconds to answer. 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, so let's take a look. All right, here we go. Let's look and see what everybody answered. We have 5 people say A, we have 1 person says B, and we have 13 people say C. So if you think about this, the force is equal on both. Now, why? Because remember, you can only hit something as hard as it hits back. Think about punching a piece of paper. If you punch that piece of paper, it doesn't hurt your hand because the piece of paper can't punch back any harder than you can punch it. If you punch the wall, though, with the same amount of effort, okay, with the same speed, if your fist is going the same speed, when it makes contact with the wall, you'll notice that you will hurt your hand. Now, why is it that the grasshopper explodes and the bus doesn't even get a change in any speed, hardly at all? And it's because the acceleration of the two things is very different. The acceleration of the grasshopper is very large because it has a very small mass. And the acceleration of the bus is almost 0 because remember, it has a lot of mass. So the forces are the same, but because there's a huge difference in mass, the grasshopper accelerates in the opposite direction, making it explode, like you see this. And then the bus really doesn't notice much of anything other than you hear a splat on the windshield. So good job. I love it. So if you're wrong, remember that's okay. we can fix these things. So it is the same for both. Let's try another one. So many people are really familiar with the fact that a rifle recoils when it's fired. The recoil is the result of something we call an action-reaction force pair. A gunpowder explosion creates hot gases. They expand outward. They allow the rifle to push forward on the bullet. Consistent with Newton's third law of motion, the bullet pushes backwards on the rifle. Tell me about the acceleration of the rifle. Is it greater than the acceleration of the bullet? Is it smaller than the acceleration of the bullet? Or is it the same size as the acceleration of the bullet? We'll give you about 30 seconds. I'm going to put in the chat again the link to the Pear Deck. So if you've been kicked out of the Pear Deck or if you just joined us, we would love to have you come in and jump in on this Pear Deck and answer some questions. Again, it is anonymous. Nobody will see your name. They might see your answer, but they won't see your name. I love all the answers you guys have here. And I think some of you are kind of getting it figured out because you're answering one thing and then you're rereading the question and the answer choices and you're changing, which I love. That's fantastic. So we're going to give you just a few more seconds here. All right, here we go. Let's check these responses. So right now we see the majority of people have answered B, but just behind it, we've got about half as many people saying that it's C. We've got some people kind of moving back and forth, which is fine too. Think about this. We know the gun has a very large mass. The bullet, if you shoot a gun, you want that bullet to come out very, very quickly. So the acceleration of the bullet, of the gun, so the acceleration of the gun should be smaller. So our answer should be letter B. So we really do want letter B as our answer. The bullet has a very small mass, has a very large acceleration, because remember, the force is the same for both. Excellent job. So the answer to that one is B. Let's go ahead and let's move on to the next thing. So here is another question. This would be a good question on the AP exam. So in the top picture below, so I know that's kind of weird, can't move it. Think about the name. Can't move it is pulling upon a rope that is attached to a wall. So can't move it, can't move it. In the bottom picture, can't is pulling upon a rope, and that is attached to an elephant. In each case, there is a scale, and it reads 500 newtons. Kent is pulling is at A with more force when the rope is attached to the wall, with more force when the rope is attached to the elephant, and the same for the same force in each case. So somebody has asked, are these kind of related to momentum? So when we were thinking about how things collide, yes, you can think about the change in momentum. So if one thing has a very large mass, it's going to have a very small change in velocity. And then the small item will have a very large change in velocity. So excellent way to think about it. Very, very good. All right, so we've got a few people have answered this one now. I think you're starting to get the hint with this one because I'm seeing a lot of the correct answer. So we'll give you a few more seconds here. And then we're going to talk about and draw some free body diagrams because those are super important. All right, let's take a look at some of your responses. So notice the predominant answer that we have here is letter C, and that would be the correct answer. In fact, if you look, the scale is reading both 500 newtons. So the force is definitely the same. The wall can only pull back on the person as hard as the person pulls on the wall. So that's 500 newtons. And because the elephant is so massive, even though the elephant could move, if the person is pulling with 500, then the elephant's going to pull back with 500. So another equal and opposite case. Thank you, Brianna, for answering that question even better. Thank you so much. That's awesome. I told you she is fantastic. Here we go. Let's take a look at the answer. There we go. It is the same force in each case. Let's think about things that you need to do before you do a problem related to forces. So the first thing is we need to make sure we know how to correctly draw a free body diagram. We must also know how to correctly draw a component diagram, but separate from the free body diagram. So I'm going to show you what I mean here in just a second. And you also need to know how to use the sum of the forces or the net force. And if you remember in our equation sheet, the sum of the forces and the net force mean the same thing. That will help us solve the acceleration of the system. So that's kind of the key. Let's go ahead and I'm going to have you do the following thing. This is what we call a horizontal or half Atwood's machine. I have a 5 kilogram mass here, and then I have a 10 kilogram mass. And notice that my coefficient of friction between the block and the table is only 0.2. I would love for you to draw a free body diagram for each one of the 2 boxes here. So on the left side, we're going to put the free body diagram for the 5 kilogram. And on the right side, we're going to put the free body diagram for the 10 kilogram box. So again, I'll put this in the chat. So 5 kilogram will be the dot on the left. And for the 10 kilogram, that'll be the dot on the right. So we're trying to draw the free body diagram. Now we're going to get a lot of great diagrams here, and we're going to take a look at all the diagrams and just make sure everybody is drawing these correctly. And remember, it's okay to be incorrect. So if you don't get this one right, that is absolutely fine. Not a problem at all. We're going to learn together. There is a text tool. So if you want to draw your arrows and then use the text tool to label, you can do that. If you'd rather draw with your mouse, or if you have a stylus and you're able to do it right on your device, that's okay too. But go ahead and label. I'm seeing some awesome answers. Seeing some answers we can learn from too. So you folks are doing great. Beautiful job. Awesome. Awesome job. Keep going. You're doing an awesome job. I'm going to give you a little bit more time on this one because it is a little bit longer question. So it takes a little bit more time for you to draw everything, especially if you're trying to do it with your mouse. There is a line tool in there. Unfortunately, there's not an arrow tool. Hopefully, they'll add an arrow tool. So if you just want to use lines and not put arrowheads on, that's absolutely fine. You do on the AP test want to make sure that you do it. All right, we're still doing awesome. I love it. Looks really good. Still seeing some great answers here. Got more and more people are finishing their answers, which is very, very nice. I like it. Beautiful job. All right, so if you're not done, that's absolutely fine. I'm going to show you some of the answers that people have. One of the things I love to do is overlay these answers so you can kind of see what it looks like, what everybody's kind of done at the same time. So you'll see all the things. You're going to see a lot of MGs pointing down, which is really good. And we see a lot of FN pointing up. So let's take a look at just some individual answers here. So remember, on the left side, we do have the 5 kilogram mass. On the right side, we do have that 10 kilogram mass. This person did a great job. So we have normal force pointing up, force due to gravity pointing down. We have a force of friction going to the left, since we do have that friction, force of tension to the right. Then the tension here is up, and the force due to gravity for the other mass is moving down. So excellent job. I love the way that this person went through, and they have put 5 and 10. Now, one thing that I also love about this answer is they used MG. I think it's really important that you use MG in order to really label what the different masses are. If you just use MG instead of M5G and M10G, you might not remember which mass is which. So this is a perfect way to label these masses. Other thing that the person put here was never forget the positive direction. Positive direction is the direction of motion. With the 5 kilogram mass, we see that the motion is to the right, so that's positive. And then the motion direction for the 10 kilogram is downward. A pulley is what you see here. The pulley changes direction. So it helps us so that we know that to the right is positive for the 5 and down is positive for the other one. I would always use MG. And the reason that I like using MG, especially if you use the mass, if you know the masses, is because when you solve problems, it makes it a lot easier. So fantastic. This person used W. That's absolutely fine too. So remember, lots of different ways to label these things, but these are awesome. You're going to notice this person even put some numbers in too. Okay. So on the AP exam, the big thing that you want to make sure you do is label all your forces and make sure that your arrows are pointing in the correct direction. Sometimes some people might take this 10 kilogram block and they'll move it up here and say that FT is to the left and MTG is to the right. You want to be careful not to do that. So just be super careful with how you're doing these. Good. Now we're going to do another free body diagram, and this is for a full Atwood's machine. So this one, what I'd like you to do is go ahead and label on the left side is mass 1, on the right side is mass 2. So mass 1 is the left dot, and mass 2 is going to be the right dot. Also notice that the size, the visual size of these masses does not tell you what their mass actually is. Instead, I put the masses up top. So it might be that mass 2 is filled with feathers and mass 1 is filled with water. So it is much heavier than mass 2, even though it looks smaller. So the volume is less, but because it's a more dense material, it is 11 kilograms. This is a less dense material, bigger volume, and it's only 7 kilograms. So one thing you just have to be careful with when you look at these. I love how you're labeling these now. I'm starting to see some fantastic ways that you're doing it. Not just using, MG, but actually using some numbers here. And I'm going to show you a couple of these because I really like what some of these people are doing. So I'm going to pull a couple of these out. All right, fantastic. Beautiful job. If you just put MG and you don't put M1, M2, or M11 and M7, that's absolutely fine. Still a correct answer. Still absolutely a correct answer. You do get a ruler on the AP test, so you want to make sure you use a ruler or a straight edge to draw straight lines. Super important. I'm going to show you a couple of answers here. This answer is really good. Always make sure that your arrows touch the dot. If they don't touch the dot, we can't count them. So please make sure that your arrows always touch the dot. And this one does. This person labeled it M11 and M7. So that's fantastic. This person, same thing, but they labeled it M1 and M2, which is very nice. Now I'm going to show you one thing, and this person's going to fix it as we go through, I think. Notice that right here, I don't see that line touching the dot. So unfortunately, I might not be able to give points for this one. This one I could not give any points for because this tension line is not actually physically touching the dot. Now, on their end, it might be. So sometimes there's a little bit of translation between the program and what they're doing. But I love all the other things that this person has put on. Do make sure when you do the free body diagrams on the AP test, you just draw the arrows and then label everything. You don't want to add anything else. All right, good job. So here is the answer that you should have. I drew this one to a little bit more of a scale. So notice that my M11G is bigger than my M7, but there's a problem. Notice that I did not make my two tension forces the same. They should be. So that's one thing I need to go back and correct. So please make sure you understand the two tensions should be the same, but M11 should be a little bit longer than M7. All right, cool. Math. When we do math with these, we need to define which direction is positive and which one is negative. So for this one, notice that M11G is in the positive direction because it's the heavier of the two masses. This FT is negative, but the FT on the right is positive. It's positive because that is the direction of motion for mass number 2. It's moving up. And the M7G would be negative. So when I do the sum of my forces, I started with the M11G, it's positive. I subtracted the FT. I added this FT, therefore the tensions cancel out. Then I subtracted M7G, and on the other side, it is the total mass times the acceleration, so I put that in. And then I solved for the actual acceleration. This is a pretty common thing that you will see on the AP exam, so you do want to get used to having to solve for the acceleration for an Atwood's machine that is moving. So one that has, I'm sorry, not just moving, but accelerating, where one mass has more mass than the other mass. If they're equal, it can move. It just moves at a constant velocity, and you got to get it started first. All right, fantastic. Now, this is the one where we have more trouble. So what we're going to do here is I want you to draw a free body diagram for the forces acting on the box. It is being pushed at a constant speed. So the sum of the forces here would equal 0, but the net force is 0, but it would be moving. And it would be moving at a constant speed because it's not accelerating. The box is being pushed at a constant speed to a vertical height of 3 meters. The person exerts a force parallel to the plane. So they are pushing up and to the left. The mass of the box is 50. They give a coefficient of friction, so you know there's friction. That's how you can tell. On the dot below that represents the box, draw a free body diagram identifying the forces, but do not put any components. It's very important that when you draw free body diagrams, you do not include the components. So we'll give you a little bit of time to draw these. I'm going to take a look at your answers and see how we're doing. Tom got a great start there. It's like Julia's got a start on it. Good. Gabriella has a good start. Awesome. Alex, I like what you did there. Alexander. Excellent. Anushka. Greta, good. Lily, good. Excellent. Very nice job. Alexander, good. Lily, you got it. Very nice job. Excellent. Good job, Spandan. Like it. Like it. Good start, Kyle. Excellent. Grace, good job. Y'all are doing awesome in this. Very, very, very nice. Brianna, thank you for answering that question. Perfect response as usual. Excellent. Seeing some awesome drawings here. I really like it. Excellent. I love it. Nice job. You guys rock this. Excellent job. Remember, don't put any components on. If you'd like to do a component diagram to the right, you are more than welcome to do that. In fact, I think our next thing to do is to redraw it with components. So fantastic job. All right, I want to show you just a few of the ones that people have drawn because they are fantastic. I love it. Very good job. All right, let's just show you a few here. This one is good. They have an applied force being up the ramp that's coming from the person on the box. There's a normal force, should be at 90 degrees. Friction force that is pointing in the opposite direction of motion for this one. Friction doesn't always have to be in the opposite direction. When a car moves forward, the friction is what causes the car to move forward because the tires in the car are pushing backwards on the ground, and then the ground pushes forward on the car with the force of friction. So just be careful with that. MG is pointing down. Very good. So here's another one that looks really awesome. An applied force. We have a normal force 90 degrees to our surface. MG is pointing toward the straight down towards the center of the earth, and we do have our force of kinetic friction. Very good. Excellent job. Here's another one. We've got another one that looks really good. So beautiful job. Okay, let's go ahead and go to the next one. This one is just the kind of what you should have. I put all four things down. You're probably going to end up with 2 points for this one. They give you 1 point for all the forces that are either parallel or perpendicular to the plane. And then they give you 1 point for mg. So this would not be worth 4 points, which disappoints a lot of people, but that's okay. Let's take a look at this one. So same thing again. I want you to redraw your free body diagram, but I want you to add the components. Add the components to your free body diagram. So be very, very, very careful. So please be very careful. So net force diagram, we just draw the forces. When we solve problems, we need the components. So you can do that on a just over on the side on the AP test, but you would not want to include them on the dots. So just be really careful. So this one you can add components on because we told you absolutely fine in the directions to add components. So label it the same way you did before, and then just add your 2 components. You guys are doing awesome. We only have about 10 minutes left. We'll have a little time for some questions if anybody has any, which is great. But some really awesome answers here. Starting to see some components starting to come together, which is beautiful. Very nice. Excellent job. So remember, if you're struggling with this is one of those things you really want to go back and review so that you know how to do. There are a ton of videos out there for you to look at. I always love to go to the Flipping Physics website and take a look there. So keep drawing. You're doing a great job. I'm going to go to the Flipping Physics website, and we'll find a video for those. We'll kind of show you what it looks like. Just kind of help you a little bit here. So always use internet resources when you can. You just want to be careful that they are reputable. Somebody that knows what they're doing. All right, beautiful job. So I'm seeing some awesome, awesome responses. I'm going to show you a couple here. The first response that we have is uses cosine and sine, and I love that. That's perfect. So the angle is right here. So our 20-degree angle is going to be just right here. But you'll also notice that this is the adjacent side, so it's mg cosine of the angle, and then the opposite side is going to be mg sine of the angle. So fantastic job on that one. This person, instead of using the cosine and sine, they've used FGY and FGX, and that would also be correct for labeling the components. If you wanted to do a problem at this point, then you'd have to go back and make sure that you use the cosine and the sine for those two things. So just a couple of things that I wanted to show you so you saw them. Next thing I want to do is show you the answer. And this is the solution. So you'll notice that we do have mg cosine of the angle. I would always draw the angle right next to the dot. If you do that, that will make everything come out so much easier. But you'll definitely want to put your angle here so that everybody can kind of see it as we go through. So this one is mg cosine of the angle. This one is mg sine of the angle. And then everything else was the same. One of the things that I really enjoy doing and kind of having you do, just as a little review right at the end of this, and we've got a little bit of time that we can do this, is we're going to play a little game. This game is only going to be 5 minutes. It is called Gimkit. A lot of people know this game. If you don't know this game, that's okay. We're going to get you on it and have you play a little bit. I'm going to put the link in the chat. So this is Gimkit.com/live, and the code to use is 55148. And if you don't mind, use your first name when you enter your name. And in this game, you're going to try to make money. It's not real money. It's kind of like Monopoly money. But the person with the most money at the end of 5 minutes is, quote unquote, the winner of the game. So it's kind of like a game show. It's a little bit like trivia night. So trivia night, if you are interested, so there is AP Physics trivia, and I know that that happens several times. So you want to do that. Anytime you want to get on and do those things, if you go to the Fiveable website, you can kind of see when it is. Brianna, when is trivia? I think it's tonight. Is that correct? I think it's tonight right after this. I will take a look while everybody's playing too. All right, so that link is in the chat. I'm going to go ahead and start the game. And when the game ends, we'll go through one more slide just to kind of show you where Discord is. But here we go. I'm going to go ahead and start it. And there's some funky music to go with it. We'll see how everybody does. Got 5 minutes for the game. Going to turn the... Yes, there's a forum after this. I forgot about that. All right, that makes more sense. Oh, it's AP Calc Trivia tonight. Folks are doing awesome. Check it out. We're already up to $139 together. Excellent job. Brianna is on it. She found trivia. It is tomorrow night, 8:30 Central Time, 9:30 Eastern Time. Thank you, Brianna, for the trivia. That's tomorrow night. Grab a bowl of popcorn, come to trivia, see how well you do. I love it. Take a look at this. You guys are doing fantastic. Hopefully you're reviewing and relearning some things you've needed to go back and do. So great, great, great job. Yeah, Brianna has also said that you can go to the forum after this, take a look at Discord, go through some components if you want to. Got about 3 minutes left here in this game here at the end, doing some awesome things. You'll notice that there's a shop button. If you click on that shop button, you can go in and buy power-ups. The power-ups allow you to earn more money per question. Some of the power-ups allow you to take the person who's at the top, or really anybody that's in it, and you can freeze them. You can give them money, make them get even more money there really quick. Yeah, Brianna also added she's going to do office hours tomorrow on Discord from 7 to 8 p.m. Central Time. So that's 8 to 9 Eastern Time. So it is a Physics 1 party, is what she says. Physics 1 party this week. Getting ready for this test. We've got about 2 minutes left here in the game, 3 minutes in the live stream. Folks are doing awesome here. Fantastic job. I love it. Got people upgrading money to the next level. We're getting closer to $1,000. I think with the time we have left, we're going to see if we make it to $5,000 or $10,000. We'll start seeing this really go up pretty quickly. Excellent job. You guys are doing fantastic. Got people buying things, buying more power-ups. I love it. If you like this, don't forget about the trivia tomorrow. Unit 2 trivia tomorrow. All about dynamics, a lot like what we're doing now. See what you know. Got a little less than a minute. We're almost at $1,000. Got 770. We need to do this for charity one night. That'd be kind of fun. Find somebody that could actually give some money. Excellent job, 818 bucks. Guys are doing great. Love it. Excellent job. All right, we've got about 22 seconds, 21, 20 seconds. See if we can hit that 1,000 mark. Buys upgrading. There we go. We hit the 1,000 mark. We're going to go up exponentially now. Got 8 seconds. All right. And perfect job. Excellent. I love it. Good job. So we've got 3rd place, 2nd place, and Spondan is in 1st place. Excellent job, guys. Hopefully you enjoyed that game. That's kind of a fun little thing to do if we get done just a little bit early. So I really appreciate you doing that. And then here is the next thing. Don't forget, you can keep the conversation going. You can go to fiveable.me/fiveable forums on the Discord channel. I'm going to put into the chat a link, and this link will give you a copy of everything we did tonight and dynamics. Here we go, Unit 2. So hold on just a second. I'll put the link in the chat. When you click on the link, it'll say that it's preparing. In about 5 minutes or less, it will be done, and you'll have a Google Doc just kind of suddenly appear, which is kind of cool. So I will put that link in the chat. If you click on that link, what's going to happen is, and I'll actually open the link here. So if you open the link, you're going to see the following thing. So you will see this, and it'll say they're carefully measuring and calculating, and then at one point you'll have a Google Doc come up that will have everything on it. Hey, I appreciate each and every one of you. Remember, we are going to meet again a week from this Saturday. We're going to talk about circular motion and universal gravitation. So please spread the word. We would love to have more people come out, but it's always great to see you guys. And thank you so much for coming. So we will talk to you later. Study hard, learn more physics. Bye, everybody. Thank you so much. You guys are awesome. Bye, everybody. Thank you. That link should be coming up here in just a moment. All right. See everybody later. Have a great weekend. Thank you, sir. Talk to you later.